Hey, this is Mr. Beckstrom, and today I want to take a look at an example from section 3.10. This is on finding derivatives of inverse trig functions. So I looked at an example that was pretty similar to number 5 in the homework, and I went ahead and copied over our main inverse trig functions for derivatives here, so you can see those for the 6 trig functions. And we're going to apply the chain rule just like we do with the normal trig function. So let's see how we would go about doing this. So here we have f of x is equal to the inverse cosine of e to the 9 cosine of x. So we just have to really make sure that we follow in the correct order. So we can really kind of look at this as, let's kind of make sure we can encompass this as kind of, g of u, as some kind of function, inside another function there. So, can I write this as f of x is equal to, one function inside another function? And I really can, right? Because this is really just the inverse cosine of some u, right? Where u is equal to e to the 9 cosine of x. Right? And so if this is the case, and I don't have to use a u, but it just kind of helps me make sure that, the entire function can be written like that. Therefore, I can use the chain rule, and if I write it like that, I can kind of go back and forth, and it helps me a little bit not get too confused. All right, so what am I going to do? Well, I'm going to apply the chain rule function. So the derivative with respect to x is equal, so, well, what's the derivative of the cosine, the inverse cosine? Well, you look over here, and the derivative of the inverse cosine, oops, I copied over the wrong ones. Alright, these are the ones that I was using. I was using the right ones, it just copied over the wrong ones. Alright, so what is the derivative of the inverse cosine function? It is negative 1 over the square root of 1 minus whatever was inside that angle squared, right? All right, so let's go ahead and write that. So this is going to be 1, back to my pen here. So 1 negative 1 over the square root 1 minus, and we're just going to use, in this case, u squared. I am not doing great today, am I? U squared times the derivative of u, right? So nice and easy. So it's this, and applying the chain rule, then we take the derivative of u. So let's go ahead and figure out what the derivative of u is going to be off to the side here. So the derivative of u is going to be equal to the derivative of this, which is applying the chain rule again. So the derivative of e to the something is just e to that something, 9 cosine of x times the derivative, so we apply the chain rule again, times the derivative of this, which is equal to the derivative of cosine is negative sine, so this is times negative 9 sine of x. So the derivative of u is negative 9 sine x times e to the 9 cosine of x. Alright, so now I know what my u prime is. I know what my u is. Let me go ahead and square out my u here. So u squared is just going to be e to the 9 cosine of x. And we just kind of multiply that by e to the 9 cosine x, and then we know going back to basic algebra that you multiply the same basis, just add the exponents. So that is just going to be E18 cosine x. Cosine x, so substituting all of this back in, the negative times the negative up here gives you a positive, so we are going to end up having what? 9 sine, 9 sine x, this is from this part up here, e to the 9 cosine x all over the square root of 1 minus that u squared, which we said was e to the 18 cosine of x. So that's that times that. And yeah. Anyways, if you have any questions, let me know. Have a great rest of your week. Thanks.